Hello my dear students, welcome to BYJU'S Exam Prep. In this particular ground zero, now we'll be starting with the next subject, that is industrial engineering. In that we'll be talking about a very interesting topic, that is the EOQ model. So let's begin the session and let's talk about what is this all about. So for understanding the basic EOQ model, the first term that you should be knowing, that is inventory. What do you mean by inventory? Many of the aspirants will be having a doubt, sir. Inventory is nothing but stock in hand, or the inventory is like the leftover material, or inventory is only about raw materials. So let us see what is the definition is telling us about. Inventory is nothing but the stock of an item or idle resources held for future use. Okay, that means all the items which we are stocking, that could be the raw material, that could be the in-process material, or that could be the semi-finished products. So all the materials which we are using for the later on uses, for stock or for later on sales, all those materials will be called as an inventory. Let us take one example to have more clarity what is inventory. Let us suppose you want to make chapati. So what you require a flour. You will be converting into a dough, and after making a dough, you will be making some chapatis, and definitely you will be stacking that inside a hot case. Okay, let us suppose some rotis is being left out and you are keeping in that hot case, right? And you are not making the chapatis for the complete dough. Some of the dough is being left out. So tell me, out of all the four images that you are seeing on the screen, which of the items will be calling as an inventory? Answer is all the items, because it's not like this. You will be purchasing every day 200 gram, or we can say half kgs of atta to make the roti. No, you'll be buying that a complete 5 kgs or 10 kgs of atta for in one go, and that you'll be using every day. You'll be taking some flour, you'll be making the dough, you'll be converting that into a chapati. Might be the chapati will be consumed, or if it is not being consumed, you'll be stacking up, or you'll be storing and you'll be using that in the later stages, right? So even the dough, if the dough is being left out, if some of the dough is being left out, or some of the flour is being left out, or some of the chapati is being left out, so all these items will be classified as an inventory. So inventory is not only about raw materials, or it's not only about the finished product. It is the all the items which includes the raw materials, the finished products, the semi-finished products, even the components which we are using, right, and which we can use in the later on stages. All these material will be called as an inventory. So we can now directly say that what is an inventory, or what are the different examples of inventory. It could be raw materials, components, work in process, and finished goods. All these categories is basically inventory, which we are using for the future sales. Okay, we are using this in the future sales, or for future use, right, in order to convert this into a revenue, right? So in inventory, because ultimately it's all about profit, all the concepts, because this is a management subject, all the concepts that you are studying, ultimate objective of understanding this concept is what is the net profit, or how much revenue you are generating, right? So definitely we are somewhere associated with some different kinds of cost. So let us understand what are the different types of costs that is being associated in an inventory. So in an inventory, the first cost that we need to understand is the purchase cost, right? The second one we call it as the ordering cost. The third one we call it as the holding cost or carrying cost, or the fourth one we call it as a shortage cost, right? All these costs is being associated in inventory cost, right? Because in order to understand the EOQ model, the basic understanding that you should be having is what is this purchase cost, or what is this carrying cost, or holding cost, one of the same thing, ordering cost or setup cost, or the shortage cost, right? So what do you mean by purchase cost? Let us suppose I need to purchase this pen. Okay, if I want to purchase a pen, right, so it is costing me rupees 100, and I want to purchase 5 pens, so the net cost will be 500 rupees. So how we calculated, per unit price into the number of units that I want, multiply, if I multiply those two parameters, we'll be getting the net purchase cost, right? So can we say the purchase cost nothing but the number of unit into the cost per unit, right? So simple example, if I say, if you are having a pen, right, and you want to, and every pen is costing rupees 100, and you want 5 pens, right, so definitely it will be costing me rupees 500. So the 500 rupees will be called as a purchase cost, right? So I can simply say, if annually, if I require 1,000 pens and each pen is costing 100 rupees, so 1,000 into 100 will be the total annual purchase cost. Or I can say, if the annual demand, if I'm denoting it by capital D, and the unit price is denoted by capital C, so can we simply say that the product of the annual demand and the unit price, the product of this will be called as a purchase cost, right? Okay, so this is a very easy thing, because we are normally using this kind of terminology in daily life also. So now let us talk about the second cost, that is your ordering cost, right? Now what do you mean by this ordering cost? What is ordering cost? Ordering cost is nothing but, let us suppose you are placing an order. You went to a restaurant, right, and you are placing like, this is the bill you are getting. So actually you ate the food which is costing you only 605, but you are paying 635. You have purchased an item for 605 rupees, but you're not paying only 605, you are paying some additional taxes. That could be your CGST or CGST, right? If you combine that, sometimes you need to give GST also, right? Or some additional taxes, okay, or some insurance cost, right? So the net price you have to pay 635. So the cost that is being associated apart from purchasing the item, that could be the transportation cost, that could be the insurance cost, right? Or that could be the cost of bringing that material to the system. Okay, so I can call that the cost that you are seeing on the screen is the ordering cost, that is 15 rupees each, right? That means approximately 30 rupees. It is nothing but your ordering cost. That means every time if you are placing this much amount of order, you have to give additional 30 rupees. So I can call this 30 rupees as the ordering cost. Okay, so I can say 605 is the purchase cost and 30 rupees that we are having is the ordering cost. And how we can calculate? Let us suppose in an year I'm placing 100 orders, okay, and cost for one order is 10 rupees. So the total ordering cost will be simple, the number of orders into the cost per order. So I can say N into CO is nothing but your ordering cost. Or what is number of orders? Let us suppose annually I'm having a demand of 1,000 units. Okay, and every time I'm ordering, let us suppose 100 units. Okay, I'm ordering every time 100 units in every order, right? So can I simply say, in order to fulfill the annual demand, which I denote as capital D, I need to place how many number of orders? The number of orders that will be equal to capital D by Q. So I can simply say number of orders is nothing but the ratio of annual demand to the order size. We call this capital Q as order size. Order size. Okay, and capital D as annual demand. Annual demand. Okay, so I can simply say ordering cost will be equal to the total number of orders placed in an year, which I'm denoting as capital N, into the cost per order. So N into CO will be giving you the formulation for the ordering cost, or I can say the annual demand by the order size into the cost per order, that is D by Q into CO, is nothing but your ordering cost. Okay, this is your ordering cost. Because in order to understand the EOQ models, you should be having a clarity what are the different costs that is being associated with this EOQ model, right? So now let us go to the next cost, that is your holding cost. Now what is holding cost? Now definitely whenever you are procuring some material, procuring means you are purchasing some material. It's not like this you will be consuming that in one go. You have to store in some storage house, right? So whenever you are keeping the items or the materials in the storage house, you should be having some proper boundary, security will be there. So definitely some amount of cost will be associated in storing that item. So all the cost that is being associated in storing the item, that we can classify under the holding cost, right? And how we can define holding cost is nothing but the average inventory for a time period into holding cost per unit time. We'll be seeing the expression later on, because it's very important that you should be knowing what's the basic understanding of holding cost, right? So all the costs that is being associated in holding that material, that could be in the storehouse, that also includes the cost of depreciation, or that also includes we can say the cost that is being associated in keeping that material in good condition. Okay, or security CCTV cameras being installed, or the security man, the armed security man. So all the cost that is being associated in keeping that material safe and sound, that cost will be called as the holding cost, right? Which we can define it as average inventory for a period into holding cost per unit time. Now, the fourth cost that you should be knowing, which is basically not being included in basic EOQ, because later on we'll be seeing the different assumptions, that is a shortage cost. What is shortage cost? Let us suppose you as a customer, you go to a shop and you see that some of the items which you require is not available. Then what happens? There will be some loss to the shop owner, right? So the cost that is being associated due to the non-availability of the raw materials or of the inventory, that cost we call it as a shortage or stock out cost. And if you see clearly, the formulation of shortage and holding cost is quite similar. Only difference is there we are talking about the holding cost per unit per time. Here we are talking about average cost per unit per time. Okay, so shortage cost or stock out cost is nothing but the average number of unit being short into the shortage cost per unit time, right? Okay, so these are the four basic costs that is being associated in your inventory cost, that is your purchase cost, carrying cost, ordering cost, or we can say shortage cost, right? We can say carrying cost or holding cost, both are basically the same thing, right? Okay, so these are the different types of inventory costs that we should be knowing before going into the basic EOQ model. Now, we are seeing again and again EOQ. What does this EOQ stands for? So let us proceed and let us talk about what is this EOQ and what is the basic significance of this EOQ and why we need to study this EOQ models in detail, right? So if you see on your screen, you might have seen sometimes in hypermarket, like sorry, these products are out of stock, right? Or you'll be having like the racks are empty. So you wanted that material, but it is not available. So there is a potential loss that has happened to the shop owner. So that loss we call it as the shortage or stock out cost, right? So now let's proceed. What is the meaning of total cost or total annual cost? So I can say whatever cost is being associated with the inventory, that could be purchase cost, ordering cost, holding cost, or the shortage cost. So summation of all the costs being associated, we call that as total cost or total annual cost. That is nothing but the summation of all the cost, right? That could be purchase plus ordering plus holding plus shortage cost. Okay, fine. Because ultimately I need to minimize this total cost, right? This is the cost that I need to pay. I need to have this cost to be as minimum as possible, or I have to optimize this value in order to get best output or maximum profit. So this is the basic objective of economic order quantity. Okay, so let's hear out what is this EOQ or economic order quantity, what is the basic understanding of that. Now let us suppose I need to procure this pen, okay, and you require 1000 units. Let us suppose you require 1000 units in a year. So there are two possibilities. Either you can procure all the 1000 units in one go, right? That means you are ordering entire 1000 units in one go. Or what you can do is you are ordering only 100 units per order. Okay, fine. So definitely if you are procuring for like 100 units per order, so definitely you need to order 10 number of times. Number of orders over here will be 10, right? Here the number of orders will be only one because you have to place order once. So definitely in both scenarios, the total cost being associated will be different because we are having the purchase cost. Definitely it is not depending on how many units, because it is simply annual demand. If I say purchase cost, nothing but annual, what is the demand into the unit price. So it is not depending on the inventory size or the order size. Q is basically inventory or order size. Okay, but ordering costs, holding costs, or shortage costs, these definitely depend on the size, order size. That means if you are procuring, let's take a simple example. If you are procuring 1000 units and you only require 10 units per day, right? So you won't be able to, you have to save 990 units on day one. So definitely it's a huge size. So the holding cost is gonna rise tremendously. On the other side, if you are procuring 100 units only, you only need to save or only need to store that 90 units being left out on day one. So managing 90 units is far more better than managing 990. So all these parameters will be coming into the picture. Let us suppose to order this product, you have to pay, let us suppose 1 lakh rupees. So definitely you won't be paying 10 times 1 lakh, because if you are ordering this material for 10 number of times, if number of orders is 10, right, then you have to pay 10 lakh rupees if the ordering cost is 1 lakh. On the other hand, over here you have to only pay 1 lakh rupees, because in 1 lakh you are getting all the 1000 units, right? So it depends upon the order size. So ordering cost, holding cost, even the shortage cost, these all depends upon the order size, which we are denoting it as capital Q. Okay, so there might be some value of this Q at which the total cost will be minimum, and that is the objective of studying this economic order quantity model. Right. So now let us talk about what is economic order quantity and what is the basic significance of studying this segment. So economic order quantity, it is nothing but it is a order size at which the total cost or total annual cost will be minimum. Right. So I can simply say economic order quantity is the size of the order which gives maximum economy, that means maximum profit in purchasing any material, and ultimately what happens, it is that optimum level at which the cost is minimum. Okay, it is that optimum level at which the cost is minimum, or I can simply say at economic order quantity the total annual cost is minimum. Right, the total annual cost is minimum. Okay, fine. So let us try to understand some assumptions. Then we'll be moving towards the economic order quantity model. Then we'll be framing one equation, and that equation, if you're able to understand, then there are other models under your EOQ models, that is your discount model, your production model, even the shortage model. That is all co-linked with this. That means if you're having a clarity in this, you won't be having any difficulty or doubt in understanding the other models, right? So that is the reason we are giving much effort in understanding the basic level of EOQ model. Other models we'll be discussing definitely in the later on stages, but before that, you should be knowing about this particular model. Okay, so I can simply say economic order quantity is that quantity at which the annual inventory cost will be minimum. Okay, fine. Chalo. So now let us talk about what are the different assumptions that we need to make, and definitely these assumptions are very important, not for examination perspective but also to understand the EOQ models. The first assumption is the demand should be constant and known. The demand that we are saying that okay, today's demand is 10 units, so that 10 units daily demand will be same if I talk about today, or even if I talk about after 50 days, it will be same. So demand is known and it is always constant. The second assumption that we need to make is your lead time will be constant and known. What is this lead time? We'll be discussing this in later on stages. By looking at the graph, you'll be able to understand. Okay, just I'm giving a rough idea. Lead time is, let us suppose today I'm placing an order for the next cycle. Let's suppose in every cycle I'm ordering 100 units. Okay, and I'm still having some units being left out before being stock out. So I'll be placing, let us suppose today is Monday. On Monday, I'm placing one order and I'm receiving that order to my warehouse on, let us suppose, Thursday, right? So that means I have taken how many days? 4 days, right? Monday complete, Tuesday, Wednesday, and Thursday, right? So Thursday evening, I'm getting that particular product. So a total number of days required, like if I say 4 number of days is required to get that material into my warehouse. I place the order on Monday, I'm receiving that on Thursday evening. So that simply means the lead time will be equal to 4 days. Okay, so lead time is the time at which I'm placing the order and the time at which I'm receiving the order. That time duration we call it as lead time, and it will be constant throughout the year. It will be constant and it will be known, right? If I talk about the next assumption on EOQ model, that is the instantaneous receipt of the material. What's the meaning of this instantaneous receipt? That means if you are going to have zero inventory, let's say to the time is 5 o'clock, at the same instant, exactly at the same instant, your next inventory will be coming into the system and your inventory will be coming back again going to maximum value. So you'll be having instantaneous receipt of the material. Practically it's not applicable, it's not possible, right? But in this we have to assume that the receipt of the material is instantaneous, right? And if I talk about the next one, the ordering costs and holding costs, we are only dealing with ordering and holding. There is no shortage allowed. Okay, that means it's not like this, the inventory will be going out of stock. Okay, so you'll be only associated with purchase costs, ordering costs and holding costs. Only three costs will be there. There will not be any shortage allowed. Okay, so that means there is no stock out. So these are the 5 assumptions of EOQ model that you should be knowing, right, before going into the economic order quantity model. Okay, so now let's see what is this basic EOQ model and what is this and how to plot the graph. And once we are able to understand the graph, then we'll be able to formulate the relations. Okay, so there are some notations that we'll be using in our graph. Capital D denotes, already we have seen that, that is your annual demand or yearly demand. Capital Q is quantity to be ordered at each point, that means your inventory size or order size. N is your number of orders being placed every year. Capital T is the time cycle for one inventory. That means if one inventory is able to sustain, it is able to from maximum to zero, it is completing in 20 days. So 20 days will be called as the inventory cycle time. Okay, and it will be always constant. It's not like this starting we're having 20 days and later on we're having 25 days. No, this time cycle for the EOQ models will always be constant, right? Capital C represent your unit price, CO represent your ordering cost per unit, and ordering cost or we can say cost per order, and CS represents your holding costs of 1 unit per year. Okay, fine. So these are the notation that we'll be using. Now let us talk about what is this graph telling us about. So this graph, we basically call it as basic EOQ model or Harris-Wilson model or infinite replenishment model. Why we are calling this as infinite replenishment model? If you clearly see at this point, this is the inventory. At the starting, we'll be having some inventory, and due to the daily usage, small d is the demand rate. Small d is demand rate. That means it could be units per day or units per week or units per month. That means the daily rate or weekly rate or bi-weekly or monthly rate, and it will be definitely a constant value. Okay, so small d represents the demand rate, and what happens is you have received the inventory, right? And on day 0, you're having this much of inventory, the maximum inventory. And once with the time, due to the consumption, your inventory is constantly decreasing, and there will be a point when the inventory is coming to a 0 value. Here, the inventory is maximum, and here the inventory is becoming 0. Okay, so you got, let's say 1000 units you are procuring, every day 10 units. So after 100 days, on the last day, you'll be having 0 inventory. And definitely, ideally, on the day when the inventory is becoming 0, on the same day, your next inventory will be coming into your storage house, right? So I can say the next day, the next inventory is coming, and that is the reason your again inventory is increasing to this. So if you clearly see, if you try to calculate the slope of this particular graph, so it will be simply, let me write it like this, dq by dt, where on the x-axis we are having time, and on the y-axis we are having inventory unit, that is capital Q. So at this point, if you try to calculate dq by dt, there is no change of time period, but the inventory is going from 0 to maximum. Inventory is going from 0 to maximum. So I can simply say at that point, your dq by dt is tending to infinity. And that is the reason we are calling this basic EOQ model also as the infinite replenishment model, because at that moment the inventory is going from 0 to maximum. There is no change in time period happening. Delta T is 0, Q is going from 0 to maximum. So that is the reason we are calling this as infinite replenishment model. Okay, so now I told you we'll be discussing lead time in this. Now if you see, every day the consumption is happening, the inventory is being consumed, right? At this point, what is happening? I am placing the order for the next cycle. Order is being placed, right? And at this point I am getting the next order at this point, because the inventory is going from 0 to maximum at this point, so order is being received at this point, right? So if you clearly see that order is placed at this point and the order received this point, so that time duration when you are placing that order and you're receiving that order, that time duration we call it as a lead time. That time duration we call it as a lead time. Okay, fine. And that inventory level at which I'm placing the order, that inventory level we call it as a reorder level. Reorder level, which we can say ROL, which can simply write it as ROL, right? Okay, so now we can simply say, by looking at the graph, the inventory at max we are having capital Q, slowly it is decreasing and reaching a point which we call it as reorder level. We are placing the next order cycle, right? And once we are placing the next order cycle, it is coming to a zero value. Once it is reaching that zero value, again the inventory has become the maximum. Okay, so this is your basic EOQ model, or your Harris-Wilson model, or infinite replenishment model. Okay, clear? So we have understood the lead time, we have understood how the inventory is going, and this cycle will be repeated again and again. So this is your cycle time. This is your cycle time, and this cycle time will be same. If you're having, let us suppose, 20 days as a cycle time, it will be same throughout the year at any instant of time. Okay, it will be same throughout the year at any instant of time, right? Sure. So now we have understood this graph. So let us now formulate the equations to have more clarity. So what we have understood that in basic EOQ model will be only associated with three different types of costs: your purchase cost, ordering cost, and holding cost, right? We have defined the expression for purchase cost. What was purchase cost? It is nothing but capital D into C, annual demand plus unit price, because total annual cost or total cost is nothing but the summation of purchase cost, ordering cost, and holding cost. What is ordering cost? The number of orders into cost per order, or I can say the annual demand by the order size into CO. Purchase cost done, ordering cost done, right? But if I talk about holding cost we were saying that average inventory. Now if I say what's the on an average inventory in one cycle, your maximum value is Q, minimum value is 0, so Q plus 0 by 2, this is your average inventory in one cycle. So I can say, if you see that your definition of the holding cost, it was average inventory for time period. So Q by 2 is the average inventory into holding cost per unit time into T, right? So this is the holding cost for time period T, for one time period T. But I need to calculate the annual holding cost. So I can say, in 1 year, how many number of this cycles will be repeated? Number of times I'm placing that order. So I can say annual holding cost will be simply Q by 2 into CH into T into N, into T into N. And what is N? N is nothing but your D by Q. And what is capital T? Capital T is capital Q by D. So if you try to multiply T into N, that will always be giving you 1. So I can simply say annual holding cost is nothing but Q by 2 into CH. So this relation, now we can simply use it over here, that your this one, annual holding cost is Q by 2 into CS. So I have formulated the results, and I have seen that the total annual cost is purchase cost plus ordering cost plus holding cost, right? Okay, so I can simply say your total annual cost is nothing but the summation of all these three terms. Okay, but at economic order quantity, what is happening? At EOQ, at economic order quantity, your total cost should be minimum, or total annual cost should be minimum. So if I want to make this minimum, so definitely I need to differentiate this term. I need to differentiate this particular summation of all the three costs, right? So I can say for minimum total annual cost or total cost. I need to differentiate this value. What is total annual cost? Total annual cost was purchase cost, that is D into C, plus ordering cost, that is D by Q into CO, plus holding cost is Q by 2 into CH. Right? So if you try to differentiate this with respect to Q and make it equal to 0, I'll be getting a very interesting relation, that is Q star. Let us assume I'm getting this value. I'm assuming this as Q star. So Q star is equal to 2DCU by CH, and this Q star, we are calling it as to be economic order quantity. That means if you are placing the order size equal to Q star, that is root of 2DCU by CH, the total cost associated with that inventory will be minimum. So that is the best thing. That is the best thing, right? So it is taking all the possibilities. It is taking into consideration the ordering cost, the holding cost, because only ordering cost and holding cost are depending on the order size. If you clearly see, if you see over here, the purchase cost, it is independent of Q term. There is no Q term. But in ordering cost and holding cost, we are having Q term, right? So I can simply say ordering cost is D by Q into CO. So if the order size is increasing, the ordering cost will be decreasing. We have seen that if you are having 1000 units as the demand, and if you are placing that all the 1000 units in one go, if you are placing that all the 1000 in one go, that means the number of orders will be 1, right? And let us suppose cost per order is rupees 100. So definitely the total ordering cost will be equal to 1 into 100, that is only rupees 100. But on the other hand, if you are placing order of 100 units in one order, right? So definitely here you need to place how many number of orders? 10 orders. So what will be the total ordering cost? 10 into 100, that will be rupees 1000. So you can see the difference. Right? So the more the order size, the less will be the ordering cost. But on the other hand, if I talk about the holding cost, what is holding cost? Holding cost is Q by 2 into CH. So if you increase the order size, what will happen? The holding cost will increase. So here you can see straightly, if you increase the order size, your holding cost is going to rise, but the ordering cost is going to decrease. You have to have an optimum value in between this, where you will be having the minimum cost. That is nothing but your Q star, that is economic order quantity. Okay, fine, economic order quantity. And we can simply say that the total annual cost was purchase cost plus ordering cost plus holding cost. And only ordering cost and purchase cost, and depending on the your inventory, I can simply say this is nothing but purchase cost plus total inventory cost or total variable cost. Okay, because ordering cost and holding cost is only depending on the order size. That is the reason we have to take as one of the costs that we can include over here is the total variable cost or total inventory cost. I can say TIC. I can say TIC. Instead of TVC, we can write it as TIC. Total inventory cost, because only ordering cost and holding cost is depending on the inventory size. So if you place this Q star in this equation, then what we'll be getting for any order quantity, we can say total variable cost is D by Q CO by C, D by Q into CO plus Q by 2 CH. But for economic order quantity, it is nothing but 2 DCU into CH, right? Okay, this is only for EOQ, only for economic order quantity. This is for any order size. You can apply this formulation anytime. You can only apply this formulation at economic order quantity. Okay, or I can say the total annual cost at economic order quantity. And whenever you are using star, that simply means we are talking about economic order quantity. So that will be equal to purchase cost plus total variable cost at EOQ. Right? Total variable cost at EOQ. Okay, so these are the different formulations for your EOQ models. Now let us take one more graph which will be telling us about the relation between or the graph between the cost versus the order size. Okay, so if you try to plot the graph between cost versus order size, so total cost you can see at this point it is minimum. So this is your economic order quantity, which we call it as Q star. Okay, because the total cost is minimum. But interestingly, what you can see that Because what is ordering cost? That is D by Q into CO. So it is inversely proportional to Q. So more the Q, the less will be ordering cost. That is being seen that with the help of this curve. If I talk about holding cost or carrying cost, it is Q by 2 into CA. That means it directly proportional. That means it will be a straight line. This is your carrying cost or holding cost. Okay, so there will be a point when both of this will be equal, and at that point we'll be having the cost to be minimum. So I can simply say there one more definition for economic order quantity. What is the definition? At economic order quantity, your holding cost will be exactly equal to your ordering cost. At economic order quantity, your holding cost will be exactly equal to ordering cost. Okay, fine. Is this clear? Very easy. So if I try to write this one more time, holding cost is equal to ordering cost. That is Q by 2 into CH D by Q into CO. If you see, you will be getting the same relation 2DCO by CH root of this. And this was the relation that we have already obtained. That is your economic order quantity. So this complete discussion, we are able to get a very important relation of economic order quantity, and also we have seen the total variable cost or total inventory cost at EOQ, that is under root of 2D COCH, right? These two relations are very, very important because normally the question is being asked from these two segments. And if you are having a clarity in this segment, then you will be easily able to understand the other models, that is production model or the shortage model or the discount model. Okay, so this completes your basic EOQ model in detail. We'll be soon seeing other segments, we'll be having other videos. So if you like and if you want all these awesome videos, stay connected with BYJU'S Exam Prep. And one more update, please, if you want any suggestions, please write in the comment section. I'll be happy to help you out. If you have more some such kind of videos, do tell me the topics. I'll be definitely happily will be making that video. Okay, so thank you guys. Stay connected with BYJU'S Exam Prep for more such awesome content. Thank you guys. Bye bye. Take care. Stay safe.